Hello Year 11 and welcome to those of you who are doing the higher tier paper. Today we're going to look at ionic half equations. First of all, we're going to start as we start every lesson with a retrieval practice. So I want you to pause the video, read through the questions and try and answer them. When you've done that, come back and we'll answer them together. Okay. Hopefully you didn't find those too difficult. Right, what is made at the anode and the cathode when molten copper bromide is electrolyzed? At the cathode, we're going to make copper because copper ions are positive and they're attracted to the negative cathode. At the anode, we're going to make bromine. Bromide ions are negative and they're attracted to the positive anode. Explain whether this reaction is reduction or oxidation. We've got a sodium ion plus an electron gives you a sodium atom. Well, this is reduction because the sodium ion is gaining an electron. Describe what happens to the chloride ions in copper chloride during electrolysis. During electrolysis, the chloride ions are being attracted to the positive anode where they are losing their electron and becoming oxidized. Describe what happens when molten zinc oxide is electrolyzed. During the electrolysis of molten zinc oxide, positive zinc ions move to the cathode, which is negative, where they gain 2 electrons and are reduced. The oxide ions move to the anode, where they each lose 2 electrons and are oxidized. 2 oxygen atoms bond together to form an oxygen molecule. Okay, let's look at our success criteria. So we just have 2 in this one. We want to be able to construct ionic half equations for reactions when the electrolysis is of a molten ionic electrolyte, and we want to be able to construct ionic half equations when the electrolysis is of an aqueous solution of an ionic electrolyte. Okay, so let's have a little recap what we learnt in our molten. The cathode is negative because it has a spare negative electrons. When the metal ion reaches the cathode, they get given a number of electrons that they need to become a metal atom. The negative electrons balance the positive charge of the cation and a neutral atom is made. So this is an example. So if we add sodium, we have a sodium ion with 1 plus. We need 1 electron for it to become sodium atom. Here's another example. We've got a magnesium ion with a charge of 2 plus. So in order for it to become a neutral atom, we need 2 negatives and it becomes a magnesium atom. And aluminium has 3 positive charges. We need 3 negative charges to balance that out and for aluminium to become a neutral atom. Okay, at the anode, non-metal ions are negative because they have extra electrons. When they reach the positive anode, they give up any electrons that they have, making them neutral. The anion loses the negative electrons until it has no overall charge. Here's an example of what happens. Now, we have chloride ions and each one of the chloride ions has 1 electron to give up. But unfortunately, chlorine atoms don't go around in singles, they go around in pairs. So they form a chlorine molecule. In order to form a chlorine molecule, they have to have 2 chlorine atoms. So that means we need 2 chloride ions to make 1 chlorine molecule. So this is the equation. 2Cl- will give us Cl2 plus 2 electrons that are donated to the anode, one from each chloride ion. And again, with bromide ions, 2 Br minus will give us Br2 plus 2 electrons given to the anode. Okay, I want us to try and learn how to do half equations for molten substances. I'm going to talk you through the first one and show you what I expect you to do, and then I'll give you a sample of 3 questions to do at a time, and then we'll come back and answer them. So we've got calcium bromide. Calcium ions are Ca2+, and bromide ions are Br-. At the cathode, we're making calcium. So what we need to do is we need to add 2 electrons to the Ca2+ to make it into a calcium atom. And we're forming calcium. At the anode, we've got bromine being made. Now, bromine is a molecule, so we need 2 bromide ions to make the bromine molecule. So the half equation is 2 Br minus gives you Br2 plus 2 E minus. Okay, right, here's 3 questions I want you to try and write the half equations for these 3. I want you to pause the video now, and we'll then come back and answer the questions. Okay, so barium iodide. Barium has a charge of 2+, and iodide ions have -1. We're forming barium at the cathode, so we've got Ba2+ plus 2 electrons will give us barium atoms. And at the positive anode, we've got 2I- will give us I2 plus 2 electrons. Sodium chloride, we've got Na plus and Cl minus. So we've got Na plus 1 electron will give us Na atoms. At the positive anode, we've got 2 Cl minus will give us Cl2 plus 2 electrons. Calcium fluoride, we've got Ca2 plus 2 electrons gives us Ca. And at the anode, we've got 2F minus gives us F2 molecule plus 2 electrons. I hope you were successful with that. Have a little look if you don't understand, and we'll come back to it later. Okay, we've got 3 more examples here, so we'll do the same as we did last time. Pause the video, read through what you're doing. 2 of them are a little harder, and see how well you do. Come back when you've answered the questions. Okay, lead iodide, Pb2+, so we're going to be adding 2 electrons to give Pb. And at the anode, we've got 2I- will give us I2 plus 2 electrons. Now, the next one, a little bit more difficult because we have an ion, an oxide ion, that has a charge of -2. At the cathode, we've got 3 electrons being added to the Al3+, which will give us Al. But at the anode, just like with the group 7 elements, oxygen also goes round as molecules. So we need 2 of them to make an O2. But as each oxide ion has 2 electrons, then 2 times 2- will give us 4 electrons that we're donating to the anode. Same thing again with the iron oxide. At the cathode, we've got Fe3+, plus 3 electrons give us Fe. And at the anode, we've got 2 oxide ions with a charge of -2, giving us an oxygen molecule plus 4 electrons. If you're having any trouble with this, then go back and just keep having a look at it and see if you understand. that's our first success criteria. Now we're going to look at how we can construct ionic half equations for the reactions with aqueous solutions. Just a little recap of what we did when we did the aqueous solution electrolysis. What are the ions that make up water? Yes, H plus and OH minus. This is how that happens. It is the dissociation of water to two ions, H plus and OH minus. This means that when we have an ionic solution, there are actually 4 different ions present. 2 of them come from the ionic compound. So for instance, if we have sodium chloride in there, we've got sodium ions and chloride ions. And 2 of them come from the water that the ionic substance is dissolved in. So we've got H plus and OH minus. Well, that's going to cause a problem when we actually get to the electrode, because we've got 2 positive ions and we've got 2 negative ions. Okay, so the rule, just to remind you, to predict the product at the negative electrode, if the metal in the compound is more reactive than hydrogen, then the product we're going to make at the cathode is hydrogen. Okay, so if we look at sodium chloride, sodium is near the top of the reactivity series and well above hydrogen. It's easier to make hydrogen than it is to make sodium. So the ionic equation for the production of hydrogen is 2H plus 2 electrons will give us H2. However, if the compound is less reactive than hydrogen, we're going to make the metal like we did when we did the molten electrolysis of an ionic compound. So for instance, copper chloride. Copper's lower than hydrogen, so it's Cu2 plus 2 electrons will give us Cu. So I've given you 2 examples up there. One where hydrogen is being made. Remember that that will be any metal in the compound above hydrogen in the reactivity series, and one where the metal's being made, and those are the metals in the compound that are below hydrogen in the reactivity series. And I've put the reactivity series here so that you can see and consult it. So what I want us to do here, because we're just doing the cathode first, I want us to predict the substance that's made at the cathode, whether it be the metal or hydrogen, and write the ionic equation for the production of that product. I'll do the first one with you. So for instance, we've got silver bromide. So silver is below hydrogen, so we're going to make silver. The ionic equation for making silver is Ag plus 1 electron, because Ag has 1 plus charge, and that gives us Ag. Now what I want you to do is I want you to pause the video now, write down the expected product that you think will be made at the cathode, and write ionic equation for the production of either the metal or hydrogen. So pause the video now and come back in a minute when you've done it. Okay, welcome back. Zinc chloride. Well, zinc is above hydrogen, so therefore we're going to make hydrogen gas. And the ionic equation for making hydrogen is 2H plus 2 electrons give us H2. Sodium chloride. Sodium is above hydrogen, so we're going to make hydrogen. The ionic equation, again, 2H plus 2 electrons give us H2. Gold nitrate. Well, gold is below hydrogen, so we're going to make gold. And the ionic equation is Au plus 1 electron gives us Au. Copper sulfate, copper's below hydrogen, so we're going to make copper. And the ionic equation is Cu2 plus 2 electrons gives us Cu. Aluminium carbonate. Aluminium is above hydrogen, so we're going to make hydrogen. And the ionic equation is 2H plus 2 electrons give us H2. Magnesium nitrate, again, magnesium is above hydrogen, so we're going to make hydrogen, and the ionic equation, again, is 2H plus 2 electrons give us H2. Lead bromide, lead is just about above hydrogen, we're making hydrogen, 2H plus 2 electrons give us H2. And that completes what we need to know about ionic equations at the cathode. Now we need to look at what happens at the anode. So just to recap for what happens at the anode, if the non-metal in the compound is in group 7, so that's fluorine, chlorine, bromine, iodine, then you will produce fluorine, chlorine, bromine or iodine gas. For example, sodium chloride solution. Chlorine will form because the chloride shows the presence of a group 7 ion, and the ionic equation is 2Cl minus will give us Cl2 plus 2 electrons. Now, the only other compounds that we're going to find will be what we call compound ions. So if it's not in group 7 and it's a compound ion, that means it's got more than one element joined together to form an ion. So like sulfate, nitrate and carbonate, the product we're going to make will be oxygen gas. So for instance, copper sulfate solution, oxygen will form. Now this takes some learning, I know, right? But this is the ionic equation for what happens to make oxygen. 4O minus, that's a hydroxide ion, make 2 molecules of water plus O2 plus 4 electrons. Okay, so we're going to do the same things we did with the cathode. I've done 2 examples at the top. An example where we have a group 7 element and an example where we have a compound ion, so not a group 7. Okay, in the first example we're making the group 7 molecule, and in the second one we're making oxygen. So what I want us to do is predict what will happen at the positive electrode, the anode, and then write the ionic equation. Okay, so I want you to pause the video now and come back when you have got the products and the ionic equations for each of the solutions. Okay, welcome back. Hopefully you didn't have too much problem with that. Okay, we've got sodium chloride. So we're looking at what forms at the positive electrode, the anode. Now chloride is a group 7 ion, so therefore we're going to form chlorine. The ionic equation for the production of chlorine is 2Cl minus gives us Cl2 plus 2 electrons. Gold nitrate, that is not a group 7 ion and it is a compound ion. So we are going to make oxygen. We're going to need that very long equation. 4OH minus gives you 2 molecules of water, 1 molecule of oxygen and 4 electrons. Zinc bromide. Bromide is a group 7 ion, so we're making bromine, and this is the ionic equation for making bromine. Zinc chloride. Chloride is a group 7 ion, so we're going to make chlorine, and this is the ionic equation that we use to make chlorine. Copper sulfate. Right, sulfate is not a group 7 ion, so we're going to make oxygen, and this is the ionic half equation. Aluminium carbonate. Carbonate is not a group 7 ion, so we're going to make oxygen, and this is the ionic equation that we use to make oxygen. Magnesium nitrate, not a group 7 ion, so we're making oxygen, and again 4OH minus gives us 2H2O plus O2 and 4 electrons. Lead bromide. Bromide is a group 7 ion, so we are forming bromine, and this is the half equation that we write to represent that. Okay, if you had any problem with that, you need to contact your teacher. Read through it all again, see if you understand it, if you go through it over and over, and then email your teacher if you don't understand. Okay, so that concludes our screencast on writing ionic half equations in electrolysis. Goodbye.